Okay. Talk about a relationship may be familiar with, but let's make sure you're familiar with. Relationship amongst the sides of a right triangle, called the Pythagorean theorem. Pythagorean theorem, like I said, is a formula, basically, about the right triangle. Now, we talked about what a right triangle is. Let's mention a couple other things here. On the sides, the two sides that make up the right angle, those are called the legs. And then the side opposite the right angle, the longest side, that is what we come to know as hypotenuse, or we do know as the hypotenuse. So the legs, hypotenuse. Now, the legs typically, they're denoted AB, and the hypotenuse is denoted as C. So that sets up what we know as Pythagorean theorem. Pythagorean theorem is this. There's a relationship always amongst the sides of a right triangle. And that relationship is, what's the relationship? The squares of the legs added together equals the square of the hypotenuse. A squared plus B squared. Square the two legs and add them together. That equals the hypotenuse squared. Probably the most famous of the right triangles is the 3, 4, 5 right triangle. If one leg is 3, the other leg is 4, then the hypotenuse is 5. And yeah, that is a famous one, if you will. And here I've got A is 3, B is 4, and C is 5. And note there that this relationship holds, doesn't it? Now, A plus B doesn't equal C. A plus B would equal 7. So it's the square of the two legs, right? 3 squared plus 4 squared equals 5 squared. And that's true, isn't it? Because what is 3 squared plus 4 squared? 9 plus 16? That's 25. And 5 squared is 25. So yeah, that's just one example of a relationship amongst the sides in a right triangle. But it always holds for any right triangle. Now, it only holds for right triangles. You know, if it's an isosceles triangle, well, there are isosceles right triangles. Better not say that. If it's a obtuse triangle, this relationship doesn't hold. Or if it's just an acute triangle, this relationship doesn't hold. It has to be a right triangle. But if it is a right triangle, all right, so let's say we've got let's say this one is, this one's 6 and this one's 9. What is that one if it's a right triangle? Yeah, what we can do is find a missing side length if we have 2 of the side lengths of a right triangle. So what I have here is, of course, A and B. I want to find C. And so I put it into the right triangle, right? I mean the Pythagorean theorem. So I have A squared, be 6 squared, plus B squared, should be 9 squared. That equals C squared. So can I find C off of that? That'd be 36 plus 81 equals C squared. 117? 117 equals C squared. So C squared is 117. What is C? We'll square root it, right? Square root of 117, which is, give or take, here, what? Square root of 117, 10.8? Yeah, that side, if this is 6 and that's 9, then that side length has to be about 10.8. It's not exactly 10.8, but it's close enough to one decimal place anyway. Now what you have to be careful with, of course, is, the question. No, 117 is c squared. So in other words, this squared gives me 117. Yeah, that's what squared gives me 117. So yeah, c is 10.8. It's the square root. Okay. Yeah, what you have to be careful with is the way it's oriented. I mean, it doesn't have to necessarily just be straight up like that. What if I had this? Kind of turned around a little bit. Let's say this one is 12.1 here. There's my right angle. And let's say this one is 4.7. What's that missing side length there? Well, it is a right triangle, so it is a squared plus b squared equals c squared. But in this case, do I have a and do I have b? No, I do not have a and b here. The 12.1 is what? C has to be hypotenuse. And the 12.1 is C, isn't it? It's the side opposite. This one we can call A, and this one we can call B, or vice versa. It doesn't really matter there. But yeah, in this case, I've got C, and then I have an A. So I've got 4.7 squared plus B squared equals 12.1 squared. That's where the pieces would have to go, wouldn't it? Or one way I could do the pieces. So in this case, I'm not adding these two here. Let's see, 4.7 squared is 22.09 plus b squared equals 12.1 squared. So, like I said, we get a little bit of algebra along the way. What am I going to have to do to get my answer? Well, am I not going to have to move that one over, subtract 22.09? And so that'll be b squared is, whatever that is, 124.32. Subtract those two. So what would b be? What b would be? The square root of 124.32. What you said was 11.1? So the missing length is 11.1. Is that okay? All right. Now, get these off of here. Let's talk back about the sum of the angles. But let's open it up a little bit and talk about the sum of the angles of any polygon. We talked about the sum of the angles of a triangle always being 180. Right? But what if it's a pentagon? Or what if it's a nonagon? Can we say definitively what the sum of the angles of those guys are? And the answer is, of course, yes. We can say what they are. But let's look at it. We know that the sum of the angles of a triangle is 180. What if it's a rectangle? Well, that's 360. Okay. That's an easy one. However, and we know it's 360. One way we know it is 90, 90, 90, 90, right? Okay. What if it's, though, not a rectangle? Get easy on myself here. Let's draw a parallelogram. What if it's some other quadrilateral? Say a parallelogram or a kite or something like that. Well, turns out, look at this. I could get my protractor out and measure that, each of those angles, but here's an easier way. Let me make a little diagonal here. I'm supposed to go straight across there. That's a little better. Okay. Make a couple of triangles out of that. What do you see in those triangles? Well, each triangle, that angle plus that angle, how much is it? That's 180. What about this triangle? That's 180. So I've got 180 degrees here, 180 degrees here. What's the sum of the angles? Without even measuring them. 360. Yeah. Turns out any quadrilateral, no matter if it's squared or not, it's 360. The sum of the angles of any quadrilateral is 360. It's four sides, it's 360 degrees. Okay? What about a pentagon? 1, 2, 3, 4, 5. Well, let's do the very same thing. Let's make some triangles here. Start here. There's a triangle. Now, the thing is, I could connect up to another one, another corner there, and make a third triangle. But again, each of the triangles is 180, so I've got 180 3 times. So the sum of the angles here for this pentagon is 3 times 180, which is 540. Okay. Well, let's do a hexagon. 6 sides. 1, 2, 3, 4, 5, 6. There's a pentagon. Here's a hexagon. See if we can figure out a pattern here. Figure out the sum of the angles there. Well, let's do the same thing. Pick a corner, any corner, and draw some triangles out. So there's a triangle. There's another triangle. How many triangles we got there?
So you have to pick one corner.
Yeah, pick one corner. Yeah. You start at one corner and just go out from it. How many triangles we have there? 1, 2, 3, 4 triangles. So wouldn't the sum of the angles be 4 times 180? 720? Okay. Let's note, though, if there's a bit of a pattern here. I think there is. We had 4 sides, we had 2 triangles. We have 5 sides, we have 3 triangles. We have 6 sides, we have 4 triangles. What is the pattern? Well, if I go to 7 sides, how many triangles am I going to have? 5 triangles, right? I'm adding a triangle. Every side I add a triangle. Now, the other component to this, so 7 sides would have 5 times 180 triangles. So 5 times 180 would be the sum of the angles for a 7-sided heptagon. But even better yet, you see how comparison-wise the number of sides compares to the number of triangles. We have 5 sides, we have 3 triangles. We have 6 sides, we have 4 triangles. We have 4 sides, we have 2 triangles. How is the number of triangles working there? It's -2, yes. The number of sides, -2, tells you the number of triangles. So if I have a decagon, let's jump to that. It'd take me a while, I'll just tell you. It'd take me a while to draw a decagon, because that's 10 sides. I could do it, but the thing of it is, I don't have to, because what would the sum of the angles be? Well, since I've got 10 sides, I'm going to have 8 triangles. So I'm going to have 8 times 180 degrees, which is 1440, I believe. Check me on that. Okay. Yeah. If you've got 10 sides, you've got 8 triangles, drawing it out this way. So yeah, if you have a polygon with n sides, then the sum of the angles equals, what would be the formula? Well, you take n minus 2 and multiply it by 180. How many ever sides there are? Take n minus 2, multiply it by 180. Okay? All right. Now, one step further with that. Let's say I have a regular hexagon. Well, it being regular, unlike the one I drew there, I tried to draw it regular, but it's kind of hard to draw those. But a regular hexagon, we know what? It has all the same sides, lengths, and all the same angles, are the same measure. Okay? So knowing that then, what is the measure of each angle? Of a regular hexagon? Well, I know the sum of the angles is 720. I've got it right there. So wouldn't each angle, we'd have to divide it up equally there? How many angles are there in a hexagon? Well, if there's 6 sides, there's 6 angles, isn't there? 1, 2, 3, 4. Yeah, 6 angles. So if there's 720 total, wouldn't I have to divide that up by 6? Each angle's got to be 720 divided by 6, which is 120. So that just adds one extra step. So let's go through the whole thing. All right. Let's say I have to find what is the measure of each angle of a regular octagon. What is the measure of each angle of a regular octagon? This is a 2-step process. The sum of the angles of a regular octagon would be what? Well, how many sides am I talking? Octagon? 8 sides. So the sum of the angles would be 2 less 6 times 180, which is what is that? 1080? 1080, okay. 1080. So I've got all total of the degrees is 1080 degrees. Each of them, though, would be what? Well, I take the 1080 and divide it up by how many? I would go back to 8, wouldn't I? Because there's 8 angles, back to 8 angles. There's 6 triangles, but there's still 8 angles. So 1080 divided by 8, what did you say? 135? All right. Is this okay? Problem or concern?